The next thing we're going to talk about is doing combinations of translations. Here we can have any combination of horizontal and vertical translations. That means we can have horizontal stretches or shrinks that change the period of the graph. We can have phase shifts, which are the same thing as horizontal shifts, either to the left or to the right. We can have vertical stretches or vertical shrinks. We can also have reflections over the x-axis. That's a vertical effect. And we can have vertical shifts, either up or down. And we can do this with either sine or cosine. Now, the way that we usually look at this with our horizontal translations is that notice our b out here has to be factored out. So what's inside of your sine or your cosine function has to be factored, so the b is out here. That way the d is going to tell you your phase shift. If you get a function that has a multiplier and a phase shift in here, then it has to be in this form. If it isn't, then you have to factor out that value of b. We'll do an example like that. When we have combinations of translations, that means that there's a lot of different stuff to look at. This is divided into 6 different steps. These first 3 all have to do with horizontal transformations. It's easiest if you do the horizontal ones first. And when you're doing the horizontal ones, there are several different ways to do this, but I find it easier to do the period first and find your interval, find the locations for your 5 key points, and then after that, do the phase shift. All of these are going to just affect the x values. So in these 3 steps, what we're doing only affects the x values of the points. Then we have the next 3 steps. Steps 4 and 5 have to do with vertical transformations, which means that these are only going to affect the y values. And then the very last step is that once you've got your 5 key points plotted, you just draw the curve through the 5 points. So here's an example where we have almost every possible kind of transformation. The only thing that's not happening in this one is reflection because we don't have a minus outside of here. Let's start with our horizontal transformations. So we have 2 things going on inside of the function. We've got a multiplier of b equals 2 that's going to change the period, and then we do also have a phase shift. So for our horizontal effects, we have b equal to 2. Our period is going to be 2 pi over 2, or just pi. That means we have 1 full cycle in the interval from 0 to pi. If we write down the x values of our original 5 key points, we're going to take each one of these and do the same thing we did with the period, which is divide by 2. If we're dividing by 2, we get 0, pi over 4, pi over 2, 3 pi over 4, and pi. I'm going to draw both of these 2 graphs on my first graph here. So I'm starting with my period going from 0 to pi, and then this is a sine graph, so it's starting at the origin and going up. So there's the graph just with the period change. Next, I'm going to look at the phase shift because this has a plus pi over 4. That means our phase shift is going to go to the left by pi over 4 units. To get that to happen on my graph, I want to take each of these values and subtract pi over 4. So here I'm doing minus pi over 4 to get my 5 new x values. So this one would be negative pi over 4. Pi over 4 minus pi over 4 is going to be 0. This is going to turn into pi over 4. This will turn into pi over 2. And this will turn into 3 pi over 4. Those are my 5 new x values for my key points. On my graph up here, I'm shifting this to the left by pi over 4. I'm starting at negative pi over 4 and I'm ending at 3 pi over 4. But there's my graph shifted to the left by pi over 4. That's all I need to do for the horizontal transformation part. Now I'm going to look at the vertical transformation. The first one that I'm going to look at is the vertical stretch. Since I've got a 3 multiplied on the outside of that, That's going to do a vertical stretch by a factor of 3. That means my amplitude is going to equal 3. This is going to affect only my y values. Basically, I'm going to take every y value that I had for these points and multiply it by 3. Instead of going to a high of 1, I'm going to go to a maximum value of 3. My minimum value is going to be -3. This is not going to change my x values at all, so I'm going to label the same locations for my key points. It's just going to change my y values. Anything that was already on the x-axis is going to stay on the x-axis. So this point is going to be at -π/4, 0. This point where my y value is 1, I'm multiplying that by 3, so I get a y value of 3. This one was on the x-axis, so that's going to stay on the x-axis. This one was at a y value of -1, so that is going to go down to -3. And then this one was on the x-axis, so that's still going to be there. So all that did was stretch my graph out vertically. The last thing that's happening here is the -1 at the end of the function. That's going to take this graph and shift everything down by 1 unit. What's going to change here is only the y values. I'm going to take each one of my y values and subtract 1. When I draw my graph down here, I want to actually go down to -4 on my y-axis. That's where my new minimum value is going to be. My new maximum value is going to be 1 below this, so my new maximum value is going to be at +2. If I take this point and shift it down by 1, that's going to move it to -π/4, -1. This point's going to move down to 0, 2. This point will move to π/4, -1. This point will move down to π/2, -4. And this point will move down to a y value of -1. Well, let's put this function into the calculator. If you're trying to graph these with your calculator, make sure and be really careful with the parentheses. So the x plus π/4 has to go in one set of parentheses, and then the 2 has to go outside of that, and then the -1 has to be outside the parentheses altogether. Here's the graph it gives me on the calculator. Really what we want to do is just check and make sure that our graph here matches what we had here. So we can see on this one that it's going up to a maximum at 2, and the minimum is down here at -4. So that matches what we had here. And it does also look like it's symmetric with respect to the y-axis. Since we phase shifted it to the left, it ended up having a maximum point right on the y-axis. And that's the same thing that we ended up with here. Now we're going to do one more example. Before we start on this problem, I actually want to change this a little bit. This was a typo. There wasn't supposed to be a 2 in there. So really what this is supposed to be is just 3x minus pi. And we can see that this graph is going to have everything going on that it can possibly have. We've got a reflection because of the minus. We have a vertical shrink. We have a horizontal shrink. This gives us a phase shift, and this gives us a vertical shift. Now, before we start working on this, though, inside of here, if we have a b, we have to have that factored out. So we want to actually rewrite this with that 3 factored out. What that means is that we're taking both the 3x and the pi and dividing them by 3. And that just pulls the 3 outside. What we end up with then in here is x minus pi/3. We're going to start with the horizontal transformations. The first thing is the b. That's going to give us a horizontal shrink. It will change our period. Since our b equals 3, that means that our period 2 pi over b will be 2 pi over 3. So we'll go through one full cycle between 0 and 2 pi over 3. For my x values, I'm going to take the x values for my 5 key points and do the same thing I did here, which is divide every one of them by 3. That gives me 0, pi over 6, pi over 3, pi over 2, and 2 pi over 3. So my beginning is at 0, my end is at 2 pi over 3. This is a graph of cosine. So we're going to start up here at the point 0, 1, go down to the x-axis, down to our minimum, back to the x-axis, and up to our maximum. The next thing that we're doing horizontally is a phase shift. Since we have a minus pi over 3 right here, that's going to move our graph to the right by pi over 3. What I'm going to do with my x values, in order to move my points to the right, I'm actually going to add pi over 3 to every one of my x values. Here I'm going from 0 to pi over 3. If I take pi over 6 and add pi over 3, get a common denominator, it ends up being 3 pi over 6, which is the same as pi over 2. If I take pi over 3 and add pi over 3, I get 2 pi over 3. Pi over 2 plus pi over 3 is going to give me 5 pi over 6. And then 2 pi over 3 plus pi over 3 is going to give me pi. These are the new locations for my points. So if I mark these on this graph, I'm starting at pi over 3 and I'm ending at pi. So I have to go a little bit farther this way to get to pi. So between here and here, I want to divide this into 4 intervals, so I've got those 4 places. Pi over 3, pi over 2, 2 pi over 3. This one is 5 pi over 6. Now I'm going to take these points and just move everyone over by pi over 3. So this one is going to move over to here. This one is going to move over to here. Again, I'm just following my pattern for my cosine graph. So there are my new 5 key points. Now I'm going to go back and label these. That gives me all of my horizontal transformations. Now I'm going to start working on the vertical ones. And this time I have 3 different things that are happening vertically. So I have my negative, which is going to reflect my graph over the x-axis. The 1/2 is going to shrink my graph vertically, and the plus 3/2 is going to shift it up by 3/2 of a unit. The first one I'm going to do out of these is the vertical shrink. What this is going to do with the 1/2 is it's going to change my amplitude from 1 to 1/2 because my A is a negative 1/2. So when I'm doing my vertical shrink, my new amplitude is going to be 1/2. That means I'm going to take every y value and multiply it by 1/2. So here's my graph with the amplitude change. All that's happening is that my high is at 1/2 and my low is at negative 1/2 instead of 1 and negative 1. But I didn't do anything to change the x values of. This just gave us the amplitude change. The other thing we want to do now is do the reflection. All that's going to do is take each one of these y values and multiply it by a negative 1. So here where I had pi over 3 1/2, this is going to flip this over the x-axis. That point is going to become pi over 3 negative 1/2. Anything that's on the x-axis is going to stay there. So this point stays on the x-axis. This point is going to flip up. This point is going to be at 2 pi over 3 positive 1/2. This point stays on the x-axis. This point flips down, and that makes that pi negative 1/2. I'm going to go back and label these other points because I'm really going to need that for the next part that I'm going to do. So this one was at pi over 2, 0. This one was at 5 pi over 6, 0. There's my graph with the vertical shrink and the reflection. The last thing that I need to do is the vertical shift. This means that I want to shift it up by 3/2. Now, if I'm looking at the graph I have here, if I shift my maximum up by 3/2, I'm taking my y value and adding 3/2. That's going to make my maximum go up to a value of 2. My maximum is going to be up there at 2, and I'm going to take my minimum value here and shift it up by 3/2. That's going to put my minimum up here at 1. So where I had the -1/2 here, that's going to shift it up by 3/2, which puts it at 1. So my graph is going to go between 1 and 2 on the y-axis. I'm just taking each one of these points and shifting it up by 3/2. So our minimum point is at 1. Then any point that was on the x-axis is going to end up at 3/2. So at this point, we'll move up to here. Where our maximum point was here, that's going to move up to a maximum of 2. This point will move up to a y value of 1/2. This point moves up to a value of 3/2 for the y, and this one moves up to 1. That way I've got both coordinates for all 5 of my key points. That's what my final graph looks like.